Friends of chemistry. Because science never sleeps, we're doing science in our pajamas this morning. And this is test 7, and we're doing problem number 7. You have two light bulbs of equal brightness. One is yellow and one is indigo. What can you say about their amplitudes? Which emits light of higher frequency? Well, if they are the same brightness and amplitude are related. So they will be the same amplitude if they're the same brightness. But because they're different colors, we have to remember our mnemonic. Rose, D, Viv. Red, orange, yellow, green, blue, indigo, violet. This is the longest, and this is the shortest wavelength. So they don't ask us about the wavelength, they ask us about the frequency. So we have to be able to recall, of course, the frequency formula, which is frequency is the speed of light divided by the wavelength. Okay, so if it has a longer wavelength, a bigger number, let's imagine, it's 7 instead of 3, a shorter wavelength. So what is this going to be, bigger or smaller, if I divide it by a bigger or smaller number? So the bigger this number is, right, the bigger the wavelength is, the smaller the frequency is. And the shorter the wavelength is, the larger the frequency is, okay? So the here's yellow and here's indigo. So this one has a longer wavelength, a bigger number, and so the frequency is going to be less. This one has a shorter wavelength, and so the frequency is going to be greater, okay? So the frequency of the yellow light is less than the frequency of the indigo light, okay? Now we're going to look at problem number 8 on test 7. Problem 8 says, what is the frequency of light that has a wavelength of 10.0 nanometers? So we're going to use this formula. The wavelength is 10.0 nanometers. A nanometer is 1 times 10 to the negative 9 meters. Okay, so 8. Frequency equals the speed of light divided by the wavelength. Okay, and the speed of light is defined for us at the top of the test. Here it says 3.0 times 10 to the 8th meters per second. Nanometers, okay, is 10 to the negative 9th. So we're going to use that so that we can have meters. Instead of saying 10.0 nanometers, we're going to express it in meters, okay? There's 1 times 10 to the negative 9th meters for 1 nanometer, okay? So it's 10.0 times 10 to the negative 9 meters. And that's how we will express our frequency, our wavelength. So the speed of light, 3.0 times 10. Be better if I could see better. 3.0 times 10 to the 8th meters per second, divided by 10.0 times 10 to the negative 9 meters. So meters will cancel each other out. I'll have 1 per second, which is the units we want for frequency. So 3.0 divided by 10.0 times 10 to the 8th minus negative 9 at 1 per second. Okay, everybody seeing what I'm doing? Let me get out of the light here. Okay, this is 0.3 times 10 to the 17th, 1 per second. But this isn't the correct way to express this. This is the scientific notation for sure. So I do want to express it with scientific notation. So I want to make this 3, and I want to express in the question, the frequency I'm given has 3 significant digits, and the speed of light that I'm given has 2 significant digits. So my answer will be expressed with 2 significant digits in scientific notation. So I'm going to say frequency equals 3.0 times 10. So let's imagine I have 0.3, whatever, 3.3 times 10 to the 17th. That's 17 zeros over here, right? So if I'm moving this over, okay, how do I deal with my, what do you call it, exponent? Blah, 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 blah. It's going to be, 0.3 times what will give me 3? 10 to the, golly, I'm losing my mind here. What do I have to do to make it 3? I have to take away 1. So it's going to be 10 to the 16th. Sorry, 1 per second. Gosh. Sorry about that, students. It's 3.0 times 10 to the 16th, 1 per second. Okay? So that's the wavelength. Excuse me, that's the frequency for number 7. We can also express that in hertz. 1 per second is equal to hertz. Okay. So I'm going to start another video for number 9.